Alright everyone, today I will be going through the solutions for the 2020 O-Level A-Math Paper 1. Now, I can say that as one of my school's top math students, speaking from the perspective of an average student, this is a pretty tricky paper. And paper 2 was also very tricky. If you actually go on to Reddit, you will actually find out that a lot of students complain about the difficulty of these papers. So let's go through the questions, and hopefully this set of solutions will also be useful for teachers who are going to use this, who are going to go through the 2020 paper as part of their TYS for their students next year. So let's get started. The first question is alpha beta. If you are going to take syllabus 4049, this question does not apply to you. The roots of the quadratic equation 2x squared minus 5x plus 8 equals to 0 are alpha and beta. So find the quadratic equation whose roots are alpha over beta and beta over alpha. Alright. So let's start off by writing down what is our alpha plus beta and alpha times beta. So sum of roots alpha plus beta is equal to minus b over a. This is your b, this is your a, so this is 5 over 2. And your alpha beta is equal to c over a, which is 8 divided by 2, which is 4. Okay, so we want alpha over beta and beta over alpha. Let's add these together. Oops, this is alpha over beta plus beta over alpha. This is equivalent to, now we just cross multiply, right? So alpha squared plus beta squared all over alpha beta, which is equal to alpha plus beta squared minus 2 alpha beta, right? And then still over alpha beta. Because alpha plus beta whole thing squared is alpha squared plus 2 alpha beta plus beta squared, so we need to take away our 2 alpha beta. So this is equivalent to 5 over 2 whole thing squared minus 2 times of 4 whole thing divided by 4. Okay, this is 25 over 4, and this is 8, which is 32 over 4. So this is minus 7 over 16. Okay, and then what is our alpha over beta times beta over alpha? This is just equal to 1. We don't even need to do any sort of calculation with these two. So therefore, the equation is, so I'm going to write it down this way. This is our sum of roots, x squared, and then don't forget this is minus, so we have to put it as plus this time. 7 over 16 x, and then our product of roots is 1, plus 1 equals to 0. This, and there's equivalent form also. You can multiply throughout by 16, then you will have a co-prime integer coefficient. 16x squared plus 7x plus 16 equals to 0. Both of these will be accepted. Question 2, part A. Given that 50 over 3 whole thing to the power of negative 2 times the square root of 3 cubed, then this whole thing divided by 5 over 2 equals to 2 to the power of a, 3 to the power of b, 5 to the power of c. Find the values of a, b, and c. Okay, so let's have a look. So this is a basic indices question. So let's simplify stuff so that we can make things easier for ourselves. This is the same as 3 over 50 whole thing squared. So this is 3 squared over, and 50 is 25 times 2. So this thing will become 5 to the power of 4 times 2 to the power of 2. Okay, times square root of something is the equivalent as raised to half power. So this is times 3 over 2. And then divide by 5 over 2 is the same as times 2 over 5. So this is times 2 times 5 minus 1. Okay, then let's express this as multiplication and put the 3's together also. So this becomes 3 and 7 over 2. And then this is 5 minus 4, 5 minus 1. So this is 5 minus 5. This is 2 minus 2. This is 2, 1. So this is 2 minus 1. So therefore your A equals to minus 1. Your B equals to 7 over 2. And your C is equal to minus 5. Follow the order as given above. Part B, the value of a painting increases by 7% each year. Given that its value at the beginning of 2014 was $1 million, find the value in 2SF at the beginning of 2020. Now, this is actually a very simple question, but many students were surprised because it seems like an E-math concept. You guys learn compound interest in E-math, but really all you need to do is 1 million times, because 7%, you put 1.07, and then you raise to the power of 6, because there are 6 years between 2014 and 2020, 2015, 2016, 2017, 2018, 2019, and 2020. You count 2020 but not 2014. Okay, you put this in 2SF, this is 1.5 million. I should put a dollar sign. It's a very simple question, but a lot of students were surprised by it because it seems like an E-math kind of concept. Question 3. Express 4x squared minus 7x plus 9 all over 2x squared minus x minus 3 in partial fractions. Now, this is a very similar question to the 2016 O-level. Their partial fractions was also the case of improper fraction and linear factors. So, of course, we need to do our long division first. If you don't do your long division, then you just lost 5 marks, okay? So, what I'm going to do is I'm going to split this into two fractions, 4x squared minus 2x, then minus 6 over 2x squared minus x minus 3, and then we need to add stuff. So we have to, don't forget to subtract another 5x, then minus 6 plus something gives you 9, that is plus 15, all over 2x squared minus x minus 3. And that is, if you would like, you can factor out the 2. Notice the algebra cancels out. You're left with 2. Okay, then minus 5x minus 15, and then we will factorize the bottom part. Okay, so 2 goes with your positive 1 and minus 3 goes with x, right? Okay, 2x minus 3, x plus 1. Okay, but for now we're going to ignore this 2. We need to split this into a certain form. So this is going to be equal to 2 plus a over 2x minus 3 plus b over x plus 1. Now we must determine each of the constants a and b to do our partial fractions. 5x, we will ignore this 2 for now. So 5x minus 15 is equal to a x plus 1 plus b 2x minus 3. Okay, so now we're going to substitute certain values of x. Let's say we sub x equals to, we want to get rid of b first, we can solve for a. So let's put 3 over 2. What do we have? This is 15 over 2 minus 15, which is negative 15 over 2. This is equal to, this will become 5 over 2a, and therefore a is equal to negative 3. Now we will sub another value of x. This time sub x equals to negative 1 because we want to get rid of this. Okay, then this becomes negative 20 is equal to, this is gone, then this is minus 5b. Therefore your b is equal to 4, positive 4. Okay, and then I shall then we need to replace this. However, don't forget that this is a negative, so I need to change this to a to a positive 3. Actually, let me just rewrite this over here. This is 2 plus 3 over 2x minus 3, and then this is 4, but because of this minus, I shall put a minus here, 4 over x plus 1. And this is your partial fractions. So Once again, similar case to the 2016 O-level, distinct linear factors and improper fraction for your partial fractions. Question 4. The diagram shows part of the graph of y equals to 2x minus 3 all over x squared plus 4. Find the values of x for which y is an increasing function. So the graph is actually not useful to us at all, but that's okay. We're still going to figure this out. First, of course, we must find our dy dx. This is your quotient rule. So we must put our bottom one first. X squared plus 4, derivative of the top is just 2. Okay, minus, put the top function 2x minus 3, derivative of this is 2x. All over x squared plus 4 whole thing squared. Okay, and this is equal to let's expand, 2x squared plus 8, then minus 4x squared, then this is plus 6x. Okay, so let's put it all together. This is minus 2x now, and then this is plus 6x. All over x squared plus 4 whole thing squared. Okay, now since, okay, first of all, we want to find this more than 0, right? Since we are finding increasing function. Since x squared plus 4 is more than 0 for all x in the set of real numbers, we let minus 2x squared plus 6x plus 8 be more than 0. Because if this is always more than 0, then this has to be more than 0 for it to be an increasing function. Otherwise, it becomes a decreasing function. So let's simplify this. This is x squared minus 3x minus 4. This is less than 0 because I flipped the inequality because of flipping the negative signs around, and I must factorize this accordingly. This is just going to be x minus 4, x plus 1 is less than 0. And of course, when you have the domain to be less than 0 for for this positive kind of polynomial, the range is bounded within a set of real numbers. It does not go to infinity. So this is just going to be minus 1 less than x less than 4. And that is your answer. I'm not sure if Cambridge still accepts set notation, but you can go ahead and put your negative infinity, negative 1, and or rather, sorry, no, you can still put your negative 1 for bracket thing if you still use your set notation. Question 5. If you are sitting for syllabus 4049, this question you can skip. The diagram shows part of the graph of y equals to modulus 7 minus 2x. The line y equals to mx minus 2, where m is a constant, cuts y equals to modulus 7 minus 2x at two distinct points. So explain why 4 over 7 is less than m is less than 2. So this is one of the harder questions in this paper. You need to do some explanation and get 4 points. A similar question actually came out in the specimen paper, where you had 3 different cases to explain, each of them 2 marks. But this time we are explaining 2 bounds, so that's why we have the 4 marks, I think. Okay, so we must think about it. What happens if we will look at this thing called the contrapositive? What happens if x is less than 4 over 7 or it is equal to 4 over 7? Okay, so let's first find this point. So min point of this part, y equals to 7 minus 2x, is, of course, when this is equal to 0, because the minimum y can be is 0, right? And then this will be 7 over 2 and 0. Okay? And now we need to say what happens if m is at 4 over 7, okay? Let's see. For line to pass through 7 over 2, 0, then and the vertical intercept is -2 already. So let's let y equals to, let's let 0 equals to mx plus c. So this is 7/2m, and then don't forget about the -2. And then what is m equal to? M is equal to 4/7, right? So therefore, to cut at 2 points, m must be greater than 4/7. So this is your 1. Okay, and then also right arm, they describe it as arm inside the specimen marking scheme as well. 7 minus 2x, where x is greater than 7/2, gradient is equal to, this is modulus, so although this is a negative, this becomes positive 2. Okay, so therefore, to cut, m must be less than 2 to cut at 2 points. And this is your number 2. Okay, because if your 2, if it's equal to 2, then it will be like parallel here, and it will never touch at the other point. And if it's more than 2, it will also never touch. So from 1 and 2, my two statements, 4/7 less than m less than 2. If you would like, you can put a lot more words down there and try to explain your best. Cambridge does not mark you down for extraneous things. So if you feel like you cannot explain everything fully, then never mind, there are still other marks to get in this paper. This is one of the more difficult questions in this 2020 paper 1. Question 6. Find the coordinates of the stationary points of the curve y equals to x squared plus 4/x squared and determine the nature of each stationary point. Okay, so we will first need to find our dy dx again, which should be quite simple. This is just 2x, and then this is the same as 4x to the power of -2. So use your power rule, bring down the -2, and then it becomes -3. So this becomes 8/x to the power of 3. Okay, so of course, to make stationary point, let dy dx equals to 0. Then what am I going to do? I'm going to multiply throughout by x cubed. So I will have 2x to the power of 4 minus 8 equals to 0. From here, I have x4 is equal to 4, and then x is the plus minus the fourth root of 4, which is the same as square root of 2. Plus minus square root of 2. Okay, you must have a plus minus. There are both solutions down here because it is an even numbers root. Okay, so let x equals to square root of 2 and negative square root 2. In each case, y will be the same because both of the terms inside the y have squares. So both of them will end up being positive anyway. So this ends up being 2 plus 4/2, which is 2 plus 2, which is just 4, okay? So both of these are going to be equal to 4. And then what is the nature of the stationary points? The square y dx square should give us the answer. This is equal to 2. Okay, and then once again, this is ax to the power of -3. Bring down your -3 and then subtract the power as well. This becomes plus 24/x to the power of 4. Okay. Then what about, oops, where's my duster? Never mind. So let x equals to square root of 2 and negative square root 2. The square y dx square, what is it equal to? So if I put it in here, this is going to become 2 plus 24 over 4, which is 2 plus 6, which is 8, which is still more than 0. if I put it into negative square root 2, once again it will be the same because the fourth power will make it positive. This is also more than 0. Therefore, because it's more than 0, both are minimum points. Minimum points at square root 2, 4, and negative square root 2, 4. Alright, this is as part of stationary point kind of question, as far as it goes, I think this is actually one of the easier ones. Question number 7. Solve the equation 3 cosine A equals to secant A minus 5 tangent A for 0 less than A less than 360 degrees. Now, when I sat down there in the exam hall to look at this question, I was a little bit scared because it was a 7-mark question, but actually it is not that bad. Alright, so we have this. Obviously, we need to get it into some form of way where we can just manipulate things easily. Luckily for us, secant is 1 over cosine and tangent is sine over cosine. So if I multiply everything by cosine, I have 3 cosine square A is equal to 1 minus 5 sine A. Okay, then what? Don't forget, cosine square A is 1 minus sine square A. So I can literally put 3 minus 3 sine square A equals to 1 minus 5 sine A. And guess what? We can form a quadratic equation in terms of sine A. So let's reorder the terms. 3 sine square A, and then minus 5 sine A, and then minus 2 is equal to 0. Okay, if you would like, you can make your substitution here. If not, we'll carry on. This is another thing we need to factorize. So this is your minus 2 goes with your 3 lah. So 3 sine A plus 1, 5, oh sorry, this is not 5, this is just sine A minus 2 is equal to 0. Just double check that that's correct. Yeah. So from here, sine A equals to minus 1 over 3, or sine A equals to 2, which has no solution or rejected. Okay, so let's go from here. Alpha is equal to sine inverse of 1/3, and therefore your A is either equal to 180 degrees plus alpha or 360 degrees minus alpha. Okay, in each case you will leave your answer to 1 dp because it is degrees. Oops, sorry about that, guys. Okay, so let me just get my calculator because I don't remember sine inverse of 1/3 in my head. Okay, this is 199.5 degrees. Over here, this should be 340.5 degrees. Yeah, okay, and these are all in 1 dp because it's degrees. So like that, all 7 marks. In any normal school prelim, this is maybe 4 or 5 marks, but Cambridge tends to overweight the marks. So honestly, right, the main takeaway here for me is don't worry so much about how many marks a question is worth, because sometimes it actually works out quite simply like this. Question 8, part A. The remainder when x cubed plus 8x, x cubed plus ax, where a is a constant, is divided by x minus 2 is the same as the remainder when it is divided by x plus 1, hence find the value of a. Okay, so we will use our remainder theorem, sum x equals to 2 and sub x equals to minus 1 in each case. So sum x equals to 2, and then we will have this is 8 and this is 2a. Okay, 8 plus 2a sub x equals to minus 1, and this is minus 1 minus a. Okay, So now we have 8 plus 2a to be equal to minus 1 minus a, since the remainders have to be the same, and then this just becomes a linear thing. So 9 plus 3a equals to 0. Therefore, your a from here is equal to minus 3. That's it. Question 8, part B. Solve the equation x cubed minus 2x squared minus 4x plus 3 equals 0 expressing non-integer roots in surd form. Okay, of course your first step is your by trial and error thing. Press calculator. If you're on a Casio, you press mode 3, 4. Not sure how you do it on other calculators, but if you know, then that's good. If you sub x equals to 3, you can try it out for yourself. Put in 3 here. This becomes 3 cubed, which is 27, minus 2x squared, which is 18, so this is 9, minus 12 plus 3, and that is equal to 0. This is 0, therefore x minus 3 is a factor. Okay, we already have one solution now, but let's just show our work. We cannot just take all the 3 numbers from the calculator like that. This will be equal to x minus 3, and then we're comparing coefficients, right? If you would like, you can also do your long division. Okay, then by inspection, what is A? It's just 1, and then C is equal to, this is 3, but this is negative 3, so this is negative 1. Okay, and then we will compare coefficients of x. Alright, so let's have a look. So this is minus 4, and then when I put x with b, this becomes b. No, sorry, if I put minus 3 with b, and then I will put this with c, minus 1 equals to minus 4. From here, our b is equal to 1, right? Okay, so now we can let x squared minus plus x rather minus 1 equals to 0, and of course to get your surd form you will need to complete the square. X plus half squared minus half squared, which is a quarter, so minus 1 equals to 0, so this is equal to 5 over 4. So x is therefore equal to negative half plus minus the square root of 5 over 4. So you either have x is equal to, so this is square root 5 over 2. Square root 5 over 2 minus half. Actually, I shall put that as square root 5 minus 1 all over 2. Or you may have x equals to minus square root 5 plus 1 all over 2. So your 3 solutions are x equals to 3, x equals to this, x equals to that. Any equivalent form will be acceptable also, as long as your surd is simplified and you have the both plus minus from your completing the square. Question 9. The equation of a circle is x squared plus y squared plus 4x minus 6y minus 12 is equal to 0. Find the radius of the center of the circle and the coordinates of its center. Okay, so this is a normal standard circles question. They give you an equation, you find the radius and center. Of course, if you know the shortcut formula, you can go ahead and do that, but I would rather show my full working, just in case. So once again, we will factorize by completing the square. So we will group the x's together. Basically what we're doing when we complete the square is get the thing in general form. So x plus 2 squared, okay, minus 4 plus, then we'll group the y's together, y minus 3 squared, and then don't forget to minus the 9, minus 12 equals to 0. So therefore I will have x plus 2 squared plus y minus 3 squared is equal to, let's get the everything on that side, so that is 25. Okay, so therefore center from the standard formula of circle, we can see that it must be -2 and +3. And radius is equal to the square root of 25, which is just +5. We don't consider the negative square root because we are doing geometry. You don't need to say reject -5. I think in this case it is quite obvious. Part 2. Find the equation of the tangent to the circle at the point 1 and 7. So for this problem, we need to keep in mind that from the center from the first part is -2 and 3. So we will find the gradient of the radius, because if I have a point on the circle and the center, then the line forming those is the radius. So y2 minus y1 over x2 minus x1, 3 minus 1 over, 3 minus 7 over, then -2 minus 1, and this is -4 over -3, positive 4 over 3. So what is the gradient of the tangent at this point? It is negative reciprocal, right? -3 over 4. So now let 7 equals to -3 over 4, 1 plus c. C is our vertical intercept for the tangent. So our c is equal to what? Okay, let's see, this -3 over 4, 7 is 28 over 4, so this is 31 over 4. So therefore, equation of tangent is y equals to -3 over 4x plus 31 over 4. Any equivalent form is also acceptable. Question 10. The diagram shows for 0 to pi, the curve y equals to cosine 2x and the line y equals to negative square root 3 over 2. The curve and the line intersect at points A and B. Find the x-coordinate of A and B. The other part is just showing all your working. Find the exact area of the shaded region. Exact is the important thing, but we're going to do this in one take. So the first part is just solve a trigo equation. Cosine 2x equals to negative square root 3 over 2. Our alpha is cosine inverse of square root 3 over 2, which is, of course, a special angle, pi over 6. And because it is negative and cosine, I can actually set x to be pi, because it's second and third quadrant, plus minus alpha, whole thing divided by 2, because it's 2x. Okay, so we have x equals to, let's take minus first. So pi minus pi over 6 is 5 pi over 6, divided by 2 is 5 pi over 12. If you do a similar thing for the other one, you will get x equals to 7 pi over 12. So this is the x coord of A, and this is the x coord of B. Cool. So just take note of this 5 pi over 12 and 7 pi over 12. Then we need to find the exact area of the shaded region, but I don't have space, so let's get rid of this. I'm just going to write it down here, just so that we have reference later on. Okay, so find the exact area of the shaded region. Okay, so we must, so let's think about it. There's a rectangle here. We need to find the area bounded under the curve, and then we need to subtract this rectangle. So this is the point 5 pi over 12, 7 pi over 12. So let me just put down points C and D here. Okay, and then area of rectangle ABCD is equal to, let's just see, so this is 5 pi over 12, 7 pi over 12. That's a difference of pi over 6, and the height is square root 3 over 2. So this is going to be square root of 3 pi all over 12. This is an exact form. Once again, they want the exact area of the shaded region. Okay. So now shaded area is equal to, now we need to put a modulus sign here. I'm not sure if syllabus 4049 still teaches area below shaded region, but anyway, this goes from 5 pi over 12 and 7 pi over 12 of cosine 2x dx minus square root 3 pi all over 12. Okay, so integral of cosine 2x, use your rules. This is sine, but you have to divide by 2. So this becomes the modulus of half sine 2x. Actually, I should put the things here. 5 pi over 12 and 7 pi over 12. All right. So this is going to be minus square root 3 pi over 12 as well. So modulus, now we evaluate whatever's inside. Put 7 pi over 12 here. Sine 7 pi over 6 is the same as sine pi plus pi over 6, which is going to be negative sine pi over 6. So this is obviously just negative half. So this is negative quarter. And then if I put sine 5 pi over 6, that is the same as sine pi over 6. That's half. Sorry, this is going to be minus another quarter. Okay, modulus of this is half minus square root 3 pi all over 12. And this is equivalent to, if you would like, you can put the terms together. This is positive half now. So this becomes 6 minus square root 3 pi whole thing over 12 units squared. This is your exact form shaded area. I know quite a lot of people who left this in not exact form, and I think they will get deducted 1 mark because of it. But they will still get the rest of the method marks. Question 11. Based on the fact that for question 11 part 2, there were many different answers by students, I think this is the most difficult question in this paper 1. A motorcyclist traveling along a straight road passes a point A and 10 seconds later passes a point B. The motorcyclist speed at B is twice at A. For the journey from A to B, the speed is given by 15 times t over 20 plus EKT, where k is a constant. Find the speed of the motorcyclist at B, find the distance AB. Okay, the first part is very easy. I'm pretty sure everyone can get it. For this, we just sub t equals to 0, because starting originally t is at 0, right? Then v is equal to what? This is 0. Anything to the power of 0 is 1. So this becomes 15. Therefore, at b, which is twice at a, it is 30 meters per second. That's just 1 mark, right? Now, distance AB. We must find the value of k first. So, let's sub t equals to 10. We will then get 15 times 10 over 20, which is 15 over 2, plus 15 EKT, which is 10k in this case, is equal to 30. And of course, if you like, let's just divide everything by 15 so our life is a bit easier. Then this becomes 2 on this side. You subtract half, it becomes 3 over 2. So e to the power of 10k is equal to 3 over 2. So therefore, your k is equal to ln 1.5 divided by 10. And this is obviously an irrational number. But I'm going to leave it in exact form because I'm going to use that to find the distance later on. So let's obtain an expression for the displacement. This is the integral of 15 times 20 is 3/4, right? 3/4 t plus 15 EKT. Okay. I'm going to leave it as k for now, dt. And this is going from 0 to 10, right? So this is a definite integral. There's no plus c here. So let's just put down our thing. This is 3 over 8t squared. And then we must divide by k on this side. Plus 15 over k EKT. And then this is going from 0 to 10. So this here is equal to what? So this is 300 divided by 8, which is 75 over 2. And then plus 15 over k e to the power of 10k. And then when we minus off, this is going to be 0. And when you sub 0 here, this is just 1. So this becomes minus 15 over k. Okay. Now, of course, this is an exact form. So we still need to find the distance. So let me press my calculator, log 1.5, whole thing divided by 10, press equal. Now I'm going to do 75 over 2 plus 15 over answer e 10 to the power 10 times answer minus 15 over the answer. And if you've done it correctly, you should get 222 as your answer. In this case, the answer is log 1.5 divided by 10. Hopefully you guys can see that it is 222, and that's 3SF. Okay. There were a lot of different answers for this question, but 222 is correct. How nice, isn't it? There's still a part 3 for the kinematics, but it is easy. Find the acceleration of the motorcyclist when t equals to 2. Okay. So we just need to differentiate this time. So when we differentiate, this is just going to be 3/4. Okay, then we need to bring down the k, 15k ekt. Alright, now we sub t equals to 2. A will then be equal to 3/4 plus 15k e to the power of 2k. And once again, you will need to use your calculator, put log 1.5 divided by 10, and then I'm going to get the answer here. So give me 1 minute. So the answer is 1.41 in 3SF. So this is quite easy, just differentiate and sub t equals to 2. Alright, question 12, the last question. Do not use a calculator. Show that this identity holds true. Okay, there's a lot of stuff to write, but I'll write it out fully for you guys. So we have sine alpha plus beta and then sine alpha minus beta. So let's put this. So this is sine alpha cosine beta plus sine beta cosine alpha plus sine alpha cosine beta minus sine beta cosine alpha. And then this is whole thing divided by cosine alpha plus beta here. So this is cosine alpha cosine beta minus sine alpha sine beta. And then plus cosine alpha cosine beta minus sine alpha sine beta. No, plus sine alpha sine beta. Okay, so let's see. Notice that this plus and minus cancel, this plus and minus cancel. So now you're left with 2 sine alpha cosine beta all over 2 cosine alpha cosine beta. And your 2's and your cosine beta cancel out. This is tangent alpha. Okay, so there you go. This is one of the most troublesome trigger proof ever, but it's okay. We can still get there in the end. And then the second part, I'm not even going to write on the board because it's very simple. Angles A and B are both acute, and sine of A minus B equals to negative 3 over 5. What can be deduced about the size of B relative to A? Not even going to write on the board. As you know, sine of any negative acute angle is a negative number. So this must mean that B is greater than A. So then find the value of cosine A minus B. Okay. So to do so, I am going to clear my board here, and I'm going to write down here. You can see that I've written stuff for your next parts. So part 3, given that sine A minus B is equal to negative 3 over 5, what is cosine A minus B? Well, cosine square A minus B is, when you square this is 9 over 25, so this is 16 over 25. Okay? Therefore, your cosine A minus B, because angles A and B are both acute, you will get a negative acute. But if it's negative acute, it is the same as the positive acute for cosine. So this is positive 4 over 5. Okay? The next part is just, given that cosine A plus B is 7 over 25 and tangent A plus B is 24 over 7, state the value of sine A plus B. Hence, using the identity from the first part, show that tangent A is 1 over 3. Okay? So with these two in mind, tangent is sine over cosine, so just times these two together, the 7 cancel out. Therefore, your sine A plus B is just 24 over 25. So let me just write down this as part 4. Okay? Part 5, now we show that if we know the A plus B and A minus B of sine and cosine, we can find tangent A. Okay? So let's just write down everything we have here. So this is 24 over 25. Actually, I don't need such a long line now. 24 over 25 plus, or negative 3 over 5, all over, this is 7 over 25 plus 4 over 5. And what's this equal to? This is negative 15 over 25. So this becomes 9 over, this is 20 over 25. So this is 27 over 25. So your 25 cancels out because there's a 25 at the top also. So this is equal to 1/3, which is shown. Okay, the last part is just find the exact value of tangent B. Okay, if you would like to see that. So to find the exact value of tangent B, we must use our addition formula. So that's tangent A plus tangent B all over 1 minus tangent A tangent B. So let's write it down. We know tangent A is 1/3 plus tangent B all over 1 minus 1/3 tangent B. And this we know is equal to 24 over 7, right? So now we are solving for tangent B. 1/3 plus tangent B is equal to 24 over 7 minus 8 over 7 tangent B. Right? Okay, so let's make one side equal to 0. Let's add 8 over 7 tangent B. So this is 15 over 7, then minus that. Okay, so 15 over 7 tangent B. 1/3 minus 24 over 7. Need to make a common multiple. This is 7 over 21, 72 over 21. So this is 65 over 21. And because 15 over 7 is the same as 45 over 21, therefore your tangent B is equal to 65 divided by 45, which I can write down as 13 over 9. Okay? And that's it. That is your tangent B. That's the entire paper for 2020 O-Level A Math Paper 1. Overall, it is a quite tricky paper, especially with a question like this and the kinematics question, but there are still many doable questions. I think there should be a good chance for people to still get an A on this paper. I'll see you guys soon for paper 2, which I feel is actually more difficult than paper 1. So, best of luck.